Now that we've reviewed all the components of sketching a curve, I want to take you through two examples that are going through the full process, basically everything that we could possibly know, and then figuring out how do we connect the dots at the end to draw a reasonable picture. When I do these problems, I like to do them in columns. So I like to do everything with the first derivative in the first column, the second derivative in the second column, and then I put a picture in the third. So I'm going to start by finding my first derivative. So power out front, power 1 less. Same thing here, power out front, power 1 less. And then I'm going to pull out an 8x squared, giving me 3 minus x. And then I'm going to list my critical values. It is really important in this topic to organize your information because now you're finding multiple things and they have multiple meanings. So you want to keep everything straight. So with my critical values, and again, if you want to do a number line, I've had students that prefer number lines instead of intervals. So we go negative infinity to infinity, 0 and 3. My derivative from negative infinity to 0, so pick any negative number like -1, I get a positive times a positive, so we start off increasing. And then from 0 to 3, we put in like 1 or 2, we get a positive times a positive again, so we're still increasing. And then from 3 to infinity, we put in like a 4, we get positive times a negative, so it switches to decreasing, which tells me that I have only one extrema. I only have a maximum. Because at 0, it didn't switch signs of the derivative. So I have my maximum at 3. And then I'm going to use a calculator. This one you might be able to do in your head, but you don't have to. 8 times 3 to the third. We're going back to the original function. To get our y component, it is 54. So that is everything that I can do and use for my first derivative. So now my second derivative, I'm going to start up a little higher so I have a little more room to work here. So my second derivative, same thing, power rule, power out front, power 1 less, power out front, power 1 less. I'm going to factor out a 24x, which leaves me with 2. Sorry, I wrote an x instead of a 2. It leaves me with 2 minus x, which means my possible points of inflection are 0 and 2. Now, one thing you can do, and I've had seen students do that, is they'll go to the same number line. I'm just going to switch colors for a second. And I'll put this new value here, and then I'll use the under part of the graph to look at the second derivative. So that is perfectly fine. Or if you want, you can create all new intervals. You really have a lot of flexibility of how you want to lay out your work because it's all for you to figure out what you need to know about this curve. So we are looking from before 0, from 0 to 2, and from 2 to infinity. So if I put a number smaller than 0 in, like any negative number, I would get a negative times a positive. So it starts off negative, which means it starts out concave down. From 0 to 2, I'm going to put 1 in, so I get a positive times a positive. So it switches to concave up. And then from 2 on, if I pick a number like 3 or 4, I get a positive times a negative. So it is back to concave down. Sometimes it's nice to kind of put it on either side of a number line because then some of the questions in Delta Math will ask, when is it increasing and concave up? Or when is it decreasing and concave up? So it allows you to really look at these intervals all at one time, which can be very helpful. So my point of inflection, both 0 and 2 end up being points of inflection because my concavity did shift. I did have a switch in my second derivative sign. If I put 0 back into the original, I get 0. If I put 2 back in, let's see again, 2 to the third, I probably can do this on the calculator, is 8 times 8 is 64, minus 2 times 16, that's 32. So 64 minus 32 is 32. Now it comes the time, and actually let's draw this. So we're going to just draw a rough sketch. It doesn't need to be perfect. I need to go all the way up to 54, so I'm going to adjust my units and go by 10. So 10, 20, 30. You'll notice on the AP test, they really don't make you graph much, so I don't want to spend a ton of time with this, but I do like how it puts everything together. So you're going to graph 0, 0. You're going to graph 232. So we'll say 232, and its approximation is right about here. And then you're going to graph 354, which is going to be somewhere up here. And you may even want to label what these things are. This is a point of inflection down here. This is another point of inflection here, and this is a maximum, just so it kind of comes together the way you want. So now I need to connect the dots. So at the beginning of this graph, and you can look at this number chart or your different intervals, my graph starts off increasing and concave down. So the way I draw increasing and concave down is I draw an arc like that. It doesn't matter how steep you draw it. Again, this is a very rough sketch that just has accurate turning points and changing points. From 0 to 2, we are continuing to increase, but there is a shift in concavity. It's a very slight shift. Some people like to draw it really gradual. From 2 to 3, we are still increasing, but now we switch concavity again. And again, concavity switch can be very subtle. And then from 3 on, we start to decrease and we remain concave down. And so that's my graph. And that's as accurate as it needs to be. If you were to graph it on your calculator, obviously change your window a little bit because your y values are pretty high, you would get a picture that's pretty similar. We have a pretty accurate way of doing this without having to rely on the technology. We're going to do one more, same process here. So we're going to do my first derivative. So 3x squared minus 9x. I can factor out a 3x, which leaves me with x minus 3. The beginning steps, it's so important that the beginning steps are right, because if they're not, then everything kind of gets thrown off. So you want to really take your time with your first steps. I'm going to do this one instead of a number line. I'll do intervals just to show you your options. It's your work. It kind of depends on how you want to lay it out. So prior to 0, if I put a negative number in, I get a negative times another negative, which is positive. So it starts off increasing. If I put 1 in, I get a positive times a negative, so it switches to decreasing. And then if I put 4 or 5 in, everything is positive, so it's back to increasing. So I actually have two extrema here. I have a maximum at 0, and I have a minimum at 3. The y values are going to be found by going back to the original. So if I put 0 into the original, I get 0. If I put 3 in, I am going to get a fraction or decimal, and that's perfectly fine. So I'm going to do 3 to the third minus 9 divided by 2 times 3 squared. I get negative 13.5. You can write it as a fraction if you want, although I think decimals are easier to consider when you graph. So then I'm going to do my second derivative. So my second derivative is 6x minus 9. So that I can take out a 3. I get 2x minus 3. So my only possible point of inflection is 3/2. So the intervals are going to go before and after 3/2. Again, if you want to use a number line and just use one number line, that's fine. Just make sure you label everything you do. So if I put 0 in, I get a negative, so it starts off concave down. And if I put a number bigger, like 2 in, I get a positive, so it switches to concave up. So I do indeed have a point of inflection at 3/2, or 1.5. This one you definitely can use a calculator to help you with your y values. They really try to avoid decimals if they can when you're not allowed to use a calculator. So I'm just going to put 1.5 in to the third power minus 9/2 times 1.5 squared. I get negative 6.75, or you could write it as a fraction. I do think decimals are just easier to picture on my graph. So when I draw my graph, 0, 0 is a point, so I'm going to put a point right at the origin. 3, negative 13.5, so 3, negative 13.5. I'm going to go by like 5s. Again, we're just approximating, so negative 5, negative 10, negative 15. So it is down here somewhere. And then 3/2, which is 1.5, negative 7 or negative 6.75. So 1/2, negative 6.75. We're going to put it right about here. And then I like to go back and label. You don't have to do this, but this is a maximum. This is a POI, and this is a minimum. So to connect the dots, my graph starts off increasing and concave down until it gets to the maximum. And then at 0, it switches to decreasing. It is still concave down until it gets to 3/2, or 1.5. And then it continues to decrease, but it switches concavity, and that's very slight. And then it gets to 3, it's increasing now, it remains concave up for the rest of the graph. They will not make you get more specific than that. They won't make you find intercepts or anything additional, But as long as you can do all these pieces, you're ready to go. On the AP test, instead of asking you to do an entire problem, you're more likely to see a part of this problem. So just asking about concavity or just asking about extrema as opposed to doing the entire thing. But this summarizes what we've done to this point.